Sup guys, welcome to today's show. So today we're gonna begin implementing Ethernet. So we are going lower level than IP. And we're gonna talk a little bit about that. But first I'm gonna talk about another project because I'm gonna use that as a base when I implement this. And that project is called Ping from Scratch, where I coded a ping utility using raw sockets. And this code is quite good to use for this purpose. I have a function for receiving an IP packet, and I'm going to rewrite that entirely. But some other stuff is quite good, and that is the constructor function, which creates an IP data structure. And when we have one of those with the IP addresses and whatnot, we can run eval IP, which turns this into a format that can be sent over the network. And I have the same for the ICMP as well, which is the protocol involved in ping. So I want to do something similar with the Ethernet. So we will have a constructor function which creates an Ethernet data structure which contains the stuff that we are interested in. So if we look at the header file, we have two data structures of each. So we have an IP data structure which only contains the interesting stuff, like the kind, the source and destination IP addresses, and so on and so forth. But in order to send it over the network, we would need to have a more involved data structure with more fields. So some of them can be calculated, and some of them we just use default stuff. And then the eval function turns this into this. And I want to do the same for the Ethernet. And then I want to turn it into a simple library that we can use to send any protocol and receive any protocol by reading and writing directly to the network card, basically. So that's the general idea. So let's get to it. I'm gonna begin by just making a copy of the entire project folder. And since this is going to be based on Ethernet, primarily, other protocols as well, I'm going to call this new project Esther. So I'm going to copy the entire ping folder into the Esther folder. Clean up a little bit. And let's change ping.c into into Esther.c. and ping.h into Esther.h. And then I'm going to open up this project folder inside of VS Code. And I'm using this Sociopath SCP client in order to code remotely, since I'm using a Linux server. Alright, so let's start by just changing the make file so it reflects our new names of stuff. So ping is going to be Esther. And same here. Sorry for the background noise. It's probably my brother's wake up alarm clock. Alright, something like that. And if you're running an older GCC version, remove this C23 thing. And by the way, you can download these ping files from repo.drbirch.com. Okay, so So let's open up these files. Let's just update the file names here as well. And maybe we should do this instead. And then we can take -i dot. So we use the current directory as a include directory. So we can use this syntax. Okay. So I'm gonna start by just deleting this receive IP function because we're gonna use a different one. Make IP, show IP, ending 16, checksum. I think the rest is probably fine. And we can remove these main functions as well because and this send ping we can also remove, I guess. Yes. Okay, so now it's a little bit cleaner and we need to remove the function signatures as well. So this we can keep. Copy checksum setup. Send ping we remove. Send IP, receive IP. We can keep the ICMP stuff. I'm not sure if we're going to use it, but it's good to have. All right, so let's begin by designing our data structure. So we're going to have a struct S Ethernet. And what do we want to keep in here? We want to have some kind of type variable here as well. So that's basically, that says what the network layer protocol is. So if it's IP or possibly something else. And then we want to have MAC addresses. So let's say we have some data type which is called MAC. And then we want to have a source address and a destination address. We need to have a payload. So we'll make an int8 array without a size, so it's variable size. And maybe we can have some kind of, what's it called? PDU type or frame type, I think. So maybe we can change this type into protocol. And we can have some kind of frame type instead. And we want this to be packed so we don't have a lot of these zeros in between. And let's type def struct as Ethernet, and this is going to be Ethernet. Maybe we can just call it ether. Like so. Okay, so we need to define what a frame type is and what a MAC address is. So let's say frame type is an enum, or E frame type. And there's a couple of frame types. Let's say we have an unset, if we haven't set this yet. And then we have unicast, which is when we send a frame to a specific destination. We have broadcast, which is when we send it to the entire local network. And then there's multicast. That's when we send it to a group of hosts. And there's also something called unknown, which basically behaves like broadcast. It's just when it doesn't know the MAC address that it wants to send it to, basically. We're probably only going to use unicast and broadcast, but let's keep those two here just in case. Let's make this packed, and we'll type def enum e frame type to frame type. And how are we going to represent a MAC address? So a MAC address, for those who don't know, looks something like this. So in Windows, it's usually represented as 6 numbers with a colon in between, and each number is 1 byte each, and that's often represented by 2 hexadecimal digits like this. And this is the hardware address. So every network card and every computer and different devices have its own MAC address, which is globally unique. And that is by every vendor of hardware is assigned these 3 first fields from IAN, I think. Internet assigned the numbers and addresses or something like this. And those 3 fields they can decide on their own. However, I want to represent it in this way instead. So it's the same numbers, but no colons, and I group them as 2 bytes each instead with a dot in between. And this is the Cisco style of representing them. And I think it's a little bit cleaner and easier to read. But that doesn't matter when we think of it in a low level, how we're going to represent it in our code. It's still 6 bytes. And that means 48 bits. And we have integers that are 32 bits and 64 bits, but we don't have any 48 bits integers. So how do we represent this thing? I think we're going to create a structure. Yeah, let's create a struct s mac yes, Mac. And inside of this we have an int64, 64-bit integer. No, what do I call these things? Yes, int64. And an int64, by the way, is an unsigned long int. And this is the address, but I only want to use 48 bits. And this is the whole structure. And we'll make it packed so we don't fill it up with zeros. And then we type def struct smac to mac, like so. And I want to start with creating a show function for the Mac, which is going to print out a MAC address in this format, because that will make stuff a little bit easier for us. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes long. So let's say we have an int8 show ether, and it's going to take a Mac pointer. Maybe yes, it should be called show Mac. So basically, we give this a MAC address data structure, and it returns a string that we can print if we want to, or use in any other occasion. All right, so let's start there. So we want to have an int8 show Mac, and it's going to take a MAC address. And let's see here. If we don't have a Mac, we will just return an error. So 0. We're going to need an int8 pointer, and we need variables for the different types, with different parts of the MAC address. So let's say the MAC address is AA, BB, C, D, D, E, FF. So we're going to have an int8 A, B, C, D, E, F. And let's also copy the int64 to a local variable to make things a little bit easier. So let's say this is the integer version. So integer is going to be equal to, and let's see here. So we take the address address, and we AND it to, let's see here, so 1, 2, 3, 4, 5, 6 bytes, and a couple of zeros in the beginning. So this is 8. So this will take only the 48 bits in case there's something else there. I don't think this is strictly necessary, but let's do it just for the sake of it. And now we need to break out each part. So let's start with the F. So we take the integer and we AND it with FF. And that's it. And to take the E, we AND it to FF00, which means we take the next byte. And we also need to push it 8 bits to the right, because at this point we take these 2 bytes, which means it's going to return something like EE00, and we need to get rid of these zeros. So we just swoosh these 8 bits to the right, and those 2 zeros will fall off the edge. So something like this. And then we continue on. So the D is going to be the same, but we add 2 zeros here, and we add 8 here. And then we keep on doing the same thing. So 32, and finally we take the A, which is 48, right? Well, we'll see, won't we? So let's say we have broken out all of this stuff here. Now we need to create a string out of it. So let's say we take the P and we malloc 16 bytes and assert that we have a P, and then we zero out that P, and then we can use snprintf to put something inside of this P, maximum 15 bytes. Okay, so we want to have hexadecimal digits, 2 each, and this is going to be an HHX, which is an 8-bit number. And then we're going to have one more of these, and then a dot. And let's copy this thing. I never do that right. And once again, so we have the first two, then a dot, then we have the second two, and a dot, and then two more. And we want to have them in the order of, let's see, I guess it would be the reverse, right? So F, E, D, C, B, A. And then we return P. Something like this. But we also need to have a constructor function so we can create one of these MAC addresses. So that would basically be all of this in reverse, right? Because we want to give it a MAC address in a string format, don't we? I'm not really sure. But let's do it like that. So we have this showMac function, and let's say we have a read Mac function. Because it's not, we don't really know if we want to have this only as a string input. Maybe we can do some kind of magic here. A little bit of, what's it called? Polymorphism. That could be kind of cool. So let's create two functions instead. So let's say we have one which is called, well, it's going to return a Mac. So let's say the first is a read Mac string. And this takes a string parameter. And we'll also have one which is read Mac int. And this takes an int 64, I guess. And then we can have, so it's not going to be a function, but we will have a macro, which we just call make Mac. And this can take an argument x, which is either a string like this or an integer. And it will call the right function depending on the input. So a little bit like, well, function overloading, I think the correct term is. But first we need to have something which does this. So let's start with the int, which is rather easy. So Mac read Mac int 64 address. need to have a Mac structure. Let's call this input and this output. And let's allocate for one of these. So let's say we have an int16 size. And Mac is equal to the MAC address casted malloc. And we take the size. First we need to calculate the size, and it's just the size of a struct s Mac. We assert that we have a Mac. And now we can just set the MAC address. No, we called it something else, didn't we? Output. So the output address is equal to the input, and we do the same thing. We AND it with 1 00 and then 1 2 3 4 5 6. And we return output. Okay, so this was rather easy. The other function will be a little bit more involved. So this is going to be a read Mac from a string, and we have an int8 input. Still have a Mac output and the size, but this time we need to do similar to what we did up there, but the other way around. So let's say we still have an int64 integer. And we need to have the different parts. So like this, int8 a, b, c, d, e, f. If we don't have an input, we can return an error. And I didn't do this check up here because an int can be 0, and that will create a 0 Mac. But if we don't even have pointer, we can't really do anything. All right, so let's see here. So now we have a string input, and we need to parse that string. Let's say we have a pointer. And a byte. And the nice way would be to do this inside of a loop, but I will be a little bit lazy now. So let's set P equal to the input. We need to parse the hexadecimal digits as well. So let's say we have some X and Y. So if we have isolated, let's say, the A's, we want to break each character into X and Y. So this will be the byte, and then we'll have X and a Y. So let our byte be equal to the current position of P, but that's not entirely true, is it? No. X will be equal to the current position of P. Then we can increase this. Then we can set Y equal to the next one. And at this point, the next, maybe I should type it in the correct format, because we want it in this format, right? So, so now we have read the A's here. So at this point, P shouldn't be 0, because if it's 0, well, it can, let's see, no, it cannot be. So if we don't have a P at this point, we can return an error. Let's say we also have an X prime and a Y prime, because currently the X is going to be equal to an A like this, and Y in this case also an A, but it's ASCII character A. We need to turn this into a hexadecimal digit A. So let's say we have some function for that. So X prime is going to be equal to the hex value of X, and Y prime is going to be equal to the hex value of Y. And now we need to assemble it together. So the byte is going to be equal to so we take the Y prime and we push it left 4 bits. And then we add the X prime. I think that is right. Yeah, something like this. And then we can set, so let's see. Then we can set a equal to the byte. And then we need to repeat this. We also need to make sure that the next character is, well, we'll do the same once again, but then we want to check that it's a dot. So maybe we should have some kind of parity bit. So let's start by setting the parity to false. And when we are done here, we're going to set parity equal to well, it's going to be XOR equal to true, I think. So this should toggle it back and forth, because if parity is false, so 0, if we XOR 0 with 1, we get 1, which is true. But if it's already true, we XOR 1 and 1 and get 0 or false. I think this will be right. And before we do that, we check if we have the parity byte set to true. That means we have done this twice, which means we want to check that we have a dot. So if P plus plus is not equal to a literal dot, then we return an error. This function became a little bit more involved than I anticipated, but never mind. All right, so then we will take this and turn it into a macro so we can repeat it without affecting our dryness. Well, let's do that now. So basically we're going to have something like define, let's call this parse mac, and it takes in this we need to do first. and the only thing it's going to take is the output. And let's continue after the break.
Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support.
Alright guys, welcome back. So, where were we? We were coding the conversion functions where we go from a string or an integer into a MAC address. And I created the code here for parsing one hex digit. No, 1 byte. So if we have a MAC address like this, we are currently able to parse 1 byte. So those A's here. And if we are on an even number, which we're not, we're on byte number 1, we check if the next character is a dot. And if it's not, we exit with an error. So first we parse the A's, then we check if we're at the right parity, which we're not, so we will continue on parsing the B's. And then we're on the correct parity, which means we're gonna check that we have this dot. And then we will continue doing this, 6 times. So let's create a macro so we don't have to repeat the code. And we're only going to take one argument, and that is the output, because the code will be the same each iteration. The only thing that is going to change is this A here. This will be a B and a C and a D and so on and so forth. But the rest will be the same. So let's do the good old while trick. So we'll do while we'll do. And let's not forget all of these backslashes. Maybe I should make some Vim script or something that lets me add those backslashes if I select a block of code. That would be kind of nifty. Maybe it's some VS Code extension or something. Right. So at the end here, we are going to say while false, which means we are not going to repeat this stuff more than once. So let's take this code block and put it inside of our H among our other function-based macros. We're going to change this A here to the output parameter. That should be it, I think. So let's see, P is equal to input. Yes, we start with that. Then we're gonna do this thing, and this is called parse mac. So we're gonna parse mac for the A. 1, 2, 3, 4, 5, 6. And then we're going to do the B and the C and so on and so forth. And hopefully by the end of this, we will have all of these variables filled out. And we are going to return one, let's see here. Well, we're going to put it inside of an integer first. So our integer is going to be, and let's remove this stuff here. And I need to look at this while I do it. So our integer is going to be, well, we're going to start with the A, and we need to push this 48 bits. And then we're going to AND it with a B, which we push. So let's see here. $40 bits. And the C is going to be 32. The D is going to be 24. E is, no, this is wrong. We need to go one step lower. So this is 40. This is 32. This is 24. This is 16. 8. And at the end here, we will just do the F without pushing it anywhere. We can, just to show our intent, push it 0 steps. And when we have the integer, we can simply return. So let's see, we don't need this output variable, because we already have this right here. Which takes an integer MAC address and produces a MAC data type. So we can simply return that function, read MAC int. And we provide our integer. And that's it. All right. It'll be very interesting to see if this works. Look at this code. It's kind of beautiful in a sense, right? All right, so how do we do this? Let's say we have a main function. We have a MAC address M. And we have a string. And here we can put it in, so let's do something like this. And then we can set M equal to Well, we're going to have a macro which selects the right one. So we should only be able to do make mac and put the string here. Let's also create an int64. So we can print this first. This is going to be show m. Let's also print the integer 0x percent long x, I guess, with 16 zeros. And this will simply be the M address. And then we want to set our N equal to M address. And let's also create an M prime. So let's see if we can go back as well. So M prime is going to be make mac, but this time we don't provide the string, we provide the integer. And then we do the same. But we provide this instead and this instead. And we leak a little bit of memory here, but I don't care since we exit the program right after. By the way, I remember we forgot to do one thing, or a couple of things actually. First of all, the show function needs to have support for our new stuff. So if we want to show a Mac, we provide the show Mac. Right, we don't have this first thing. We can add that later, but perhaps. So we want to have a MAC address of X, like so. And eval we haven't done yet, but we want to do something similar for the different parse functions. So what did we call those? Readmac string and readmac int. So we want to have one which is called make mac, takes in an x and we want to do a generic of x, and if we provide an int64, we want to call parse mac, no, read mac. So read mac int in this case. We cast this to an int64. And if we have a string, we do read mac string. Let's not forget the backslashes. Like so. And we need to do one more thing, this hex thing. We need to be able to turn a character, so a hex value inside of a character, ASCII character, into a regular hex character. And I guess we can do that inside of a macro. So let's say we have an hex which takes in an x. And if the x let's see here, if the x is less than or equal to, no, if it's more than equal to the character a, or if x is less than or equal to the character f. In that case, we want to return, what do we want to return? Well, we want to return a 0xa minus the character a minus the hex character a. Let's see here. I think I need to do this here. So what is the character A? 61. And we want to turn this into a 10. So what is 0x61 minus 0x10? 81. And the hex version of 81 is 51. So if we remove 51 from our x, we will get the right thing. So x minus 0x51. That's the result in case we are between the range A to F. Otherwise, we want to take our x, but this time minus a 0 as an ASCII character. Yeah, I think that's right. All right, a lot of moving parts here. Let's see if it compiles. Quite many errors, but probably most of these will be removed once we fix single error. X minus this expected a parenthesis. Right, we forgot backslashes as usual. Expected need a comma here. If Mac 312 this should be address. Pointer targets in passing, blah blah blah, 326. We need to cast this into a character. Warning, left shift count more or equal to the width of the type. $366. So maybe we need to do something like this. no. This, I guess. We need to add int 64. Same here. I love the dot function. No. We need to have the cast around the A. So like this. Right, unused variable 346. We're down to about one page. Conflicting types for main. Blah 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 377. I guess we need to do this. Cast from pointer to integer of different size. Huh. That's a little bit weird. And this was a little bit funny. The format expects type long unsigned int, but it has long unsigned int. Oh, 48, okay. So let's fix that first. Something like that. Return with no value. That is true. What else? Okay, so we're down to a couple of warnings, and I'm not really sure why it complains, because the whole point of the generic is to let us do what it's complaining about. But it does not complain with the old stuff we had, so what's different? The parentheses. But here it works. It's weird. What's different? Read Mac int 64 of x, and x is an int 64. What if we weren't casting and just saying x here? Does that make a difference? Nope. Maybe we can ignore that warning. I'm not sure why it's there. Alright, let's try this out. Okay. M is equal to null. So it fails parsing. And what if we weren't starting with a string? What if we just put an int 64 here instead? So 0, 0, 01, 38, FB 99, AA. So something like this. Okay, now something happened. This worked. We get the right thing. And here, and here. So it's a string parsing that fails somehow. And why is that? So let's do something like this. We put this on the right side of the screen so we can look through this macro. So we set P equal to input, and then we parse the A. So output is going to be A, and the parity is false. So we make sure that we get the two characters. Maybe this is the problem, because it has to end sometime, right? But we should be able to parse all the way to F. No, at F it's going to be a 0 here. So how do we perform this check? Let's remove it for now. Okay, that's not it, I guess. Alright, so x points to the first A, and this to the second. And we swap x for the right value. We OR them together to get a byte. The output is equal to that. And if parity, which it's not at this point, and here we set it to 1, to true. So we have parsed the A. Then we do the B, which is going to be the same thing. Only this time we have parity. And we check that the current position is a dot. And if it's not, we return an error. So it must be this, right? That's the only place where we return this 0. So we have a string like this: A, no, A, B, C, C, D, D, and so on. So we start here, then we increase and increase. Then we don't check for the dot, then we increase, increase, then we do check for the dot. Maybe we can do a temporary thing here. Let's print the current position. So something like this. And then we can see what's going on. Dot, dot, nothing. Okay, so when we have parsed the f, it's going to be nothing. So we need to check first that we have a p. Do something like this. And now it works. Beautiful. But it doesn't look quite right, does it? I think we need to look through the math, but the actual parsing seems pretty okay. It's probably the hex function which doesn't work as intended. So after the break, we take a look at that. See you in a bit. Alright, you guys, welcome back. So before the break, we managed to successfully, or almost successfully, parse this thing. And I think the hex macro is the culprit, but I'm not 100% sure. So let's test it out. Let's just add something like, no, this is wrong. Let's go to the main. And let's say this is main 2. Main 2. And the regular main will just return main 2. Or rather, this is main 1. And now we're going to create a main 2. This makes it a little bit easier for us to debug and such things, test different versions. So in here, I will just have a single printf. And what I want to print is 2 hex characters. So %02hhx, and the same thing once again, where the first one is character A, second one character 5, let's say. And I guess we need to cast these to a char. Something like this. And by the end of this thing, we're going to add some signatures for the other main functions. So we have int main1 void into main2 void, and I'm gonna put a space in before this one to indicate that they are temporary things. Ten and 4. E4 even. So I did those calculations wrong, I guess. If x is more or equal to the character a. So this is true in the first case. So then we take x minus 51. And if we print the a and hex them, so that is 61. So we have 0x61 minus 0x51, which is 16. We want this to be 10, not 16. So what we really want is 51 plus 16. So that's 97, or in hex 61. That's not right either. Well, we don't want this to be 16. We're 6 off. So plus 10 to this. Hex 0x91. 5b. We're still off. So b plus 4. So 1, 2, 3, 4. We go the wrong direction. So where were we? We were at B. So 1, 2, 3, 4. There we go. And what about this second case? X minus 0. So we have the 5. And a 5 translates to 35. And the 0, 30. So we have 35 minus 30. which is 5. So why doesn't that work? X minus 0. 35 minus 30. What if we put in, that should make a difference, right? Oh, wait a minute. This should be an and, not an or. There we go. All right. So if we go back to main number 1, this time I believe everything should work as intended. Almost. So let's see, we start out with this. AA99. Okay, so we have the right values, but in the wrong order. Still doesn't look quite right. Okay, so we have swapped the individual bytes as well. So I guess we should take the X here and the Y here. FB990. FB99, almost, the last one didn't become the right thing, but everything else. So why is that? Must have to do something with this, maybe. Everything is right except the last one. Okay, so A becomes 0. And A is the first thing we parse. Weird. Maybe it's not the string parsing function that is the problem. Maybe it's the show function or something. Yes, this should be 40. That's why. And there we go. All right, so now we can successfully parse the stuff and print it and stuff like this. So now we can actually start coding the inner workings of the Ethernet implementation. So what we need to do is we need to take a look at the protocol. So let's search for Ethernet wiki. Let's see. Give me the English page, please. So let's see if we find a packet format or frame format. Can we just get the frame format here? Okay, here we go. It's a weird presentation. Usually we don't see the preamble and that stuff inside of this, I think. But okay, let's do that. So let's create a struct based on this thing. So we already have our own Ethernet structure, but this is going to be the raw thing. So raw ether. So 7 bits of preamble. And we need to consider network byte order here as well. So for instance, here we have a byte, but we need to put this before the preamble. And here it's a little bit tricky determining the order. So here we have 12 plus 4 is 16. So this is an int 16, and we need to reverse this order. So it's a little bit tricky here, but I think we're gonna figure it out. So let's start with this preamble thing. So it's going to be an int preamble with 7 bits, and then we need to place this SFD before the other thing, which means that this is going to be a bool. SFD1. So this is 1 byte. Then we take the 16-bit thing of this one, starting with a VLAN tag. But I wonder, it says it's optional, but what happens if we omit it? Let's keep this for now. We might be able need to change this later on. 4 bits of VLAN. So this is going to be an int 16 VLAN 4, and then we go backwards. So we have the source and then the destination. So this is the let's see here. No, I'm thinking I'm doing this wrong. Because these are 6 bytes, not 6 bits. Okay, it makes things trickier but also nicer. Let's do this again. Alright, so now we can take it in order at least. Start with the preamble. So we need 7 bytes for that. So 7 bytes. And int 32 is 4. And int 64 is 8 bytes. So we can think the same way as before, only using an int 64 instead. So we start with the SFD, and this is 8 bits. And then we have the rest of this int 64, which is the preamble. And this is 8 times 7, so it's 56 bits. Alright, and then we have our 2 MAC address structures. Actually, I think we should have them in this order. So we have this destination and the source, like so. Then we have the optional VLAN tag, which is 4 bytes. So that's an int32 then. Is it really 4 bytes in size? So VLAN, and then we have the type, which is an int16. And then we have the actual packet, which is variable size. And that is generally an IP packet. And that's the only thing we'll support, I guess. So this would be a raw IP packet right here, or a pointer to it. No, the real thing. But it includes its payload as well. So let's say we have a struct s raw IP payload, and then 4 bytes of CRC. An interpacket gap. It seems like these stuff here and here is not what things that we're going to have to tell it, because I think the network card should handle that stuff, but I'm not entirely sure. I haven't really done this type of packet before, because we're not doing raw sockets any longer. We are doing something called, let's see, raw socket, raw packets. I need to check. So raw. I think it mentions that kind somewhere here. I think it's called packet. Sock raw. This is probably it. AF packet. Net ethernet.h. Maybe that shows the syntax, how much of the actual packet we need to use. So user include I6, X6, I3, and net. Okay, here we go. Ether header. So destination host, source host, type. That's all. The rest is handled by the network card. Yeah, easy peasy. So we can clean out all of this stuff here. So we have the destination and the source in that order, right? Yes. No VLAN, the type we keep, the payload we need to keep. Let's see, how did we do the other protocols? For ICMP, we had this data field at the end. For IP, we didn't have any of this. So the CRC we don't have to bother with either. Maybe we should make this easy on ourselves and just do something like this. And we need this to be packed though. So when we evaluate this thing, we are going to turn this structure into this. So actual raw bytes. And then we can just assemble all of this stuff. So we take one of these and then one of the IP, and then we need to create something similar for TCP and UDP. And then we can basically deal with any protocol. So how did we do, let's see here, eval IP. So we fill in all the different stuff. And this was a little bit more involved than what we have to do right here. And we also deal with the payload here. So maybe we should do that after all. And then we just return an int 8, so the raw bytes. Okay. So we're gonna have an int 8 eval IP, no, eval ether, and this takes an ether pointer. Maybe we don't need to deal with unknown and multicast. Alright, so let's see if we can write this function. Shouldn't be too difficult. So we're going to return an int 8 pointer. This is going to be called eval ether. Going to take an ether e, let's say. We need to have pointer. We need to have something for the size. We need to have a struct s raw ether raw. And if we don't have an e, we're gonna return 0. We can start by clearing out our raw packet. Need to have the size of it first. Size of struct s raw ether. Maybe we can make this a pointer actually. And we can set p equal to malloc size bytes. We can assert that we have a p. Then we can zero out that p size bytes. And when we have the room for this structure, we can set our raw equal to this struct s raw ether of p. And now we just need to fill in the blanks. So the p destination, no, the raw destination is going to be the e destination. I think we can do it like this. Let's try anyway. And the raw source is going to be the e source. And the raw type is going to be we do want to support ARP2 though. So we need to have some way of distinguishing. So we have the frame type. Maybe we should just have an ether type. Where we have type or type IP, and that is 800, and type ARP is 806. And maybe we have some T other as well. Or let's not. So So now we can just set the type to e-type or ether type. No, what we do call it? We called it type, but we need to rename these things. So this is now an ether type. Same here, ether type, like so. And now we should just be able to get this as type. And these are the only three things we need to fill in. Well, let's start there. We can deal with the payloads a little bit later. For now, let's just return this thing. So now we can evaluate one of these things. And we need to create a constructor function for this as well. Oh, wait a second. Protocol. That's probably what this is referring to. So we can remove this protocol. We can change this to protocol. And we have the source, the destination, and possibly some data. And how does the function for make IP look? Okay, so we take all of these different things, but no payload. Okay, so we create an empty payload and then we can add it manually. And here we only support ICMP, but we are going to add more there. So we can just do IP payload. So let's create this constructor function. So it's going to return an ether, make ether, and it's going to take a destination, source, ether type. So something like this. So make ether, and we have an ether type, type. We have a MAC destination and a MAC source. If we don't have a MAC or a source or a destination, can return an error. So the size is going to be equal to the size of a struct S ether. E is going to be malloced with this size. We're going to zero out this with the size. Then we're going to start filling in the fields. So the E protocol is going to be equal to type. The E destination, and this is, well, it's going to be equal to this, right? And the E source equal to this. And that's it. Well, we're going to set the payload to 0 for now. And then we return E. Oops, that's a couple of errors. Unknown type name, IP. 84. I think we have a little bit of ordering problem here. So let's take this thing and move it down a notch. Here perhaps. 403. Right. is equal to struct s raw ether 406. Well, it's going to be a pointer, shouldn't it be? So now we're back at those warnings that we had before. But everything compiles. Alright, so now we have successfully taken care of the parsing of the MAC addresses, some of the show functions, converting back and forth, and also a constructor function for our Ethernet data structure, and the raw version which we can send over the wire, which we get by evaluating the Ethernet data structure. So we have laid a solid foundation here, and in the next episode we are going to take care of the send function for actually sending one of these things. I hope you liked this episode and that you want to continue watching this series. Please like and subscribe, and thanks for watching. Thanks for today.